We have all heard about how a retailer like Target predicted that a high school student was pregnant before her unsuspecting parents did. More commonly, we see targeted ads based on our previous browsing history. This is an example of one of the many applications of machine learning, where patterns are sought from seemingly disparate pieces of data. Data is the cornerstone of every good discovery. From data, we derive knowledge. Knowledge derived from data is powerful because one who utilizes knowledge can gain some sort of advantage. In medicine, this may be the use of a new drug to improve disease outcomes or a method to prevent in-hospital adverse events. It stands to reason that in order to make good predictions, we need good data. The goal of this short tutorial is to familiarize a researcher with the data lifecycle and briefly introduce the available informatics tools in each step. Data management can be broken down into an 8-step data lifecycle, starting in research planning all the way to the analysis and interpretation. In each step, we could think of best practices that ensure the optimal collection, security, annotation, preservation, and analysis of our research data. Step 1 of the data lifecycle is planning. During research planning, researchers need to determine how data will be collected, stored, and analyzed. Informatics approaches which can aid in this step include the use of protocol authoring tools, which enable more efficient collaboration among different investigators. Step 2 of the data lifecycle is data collection. It is important to collect data in such a way as to ensure its usability later. Careful consideration of data collection methods and data documentation is important at this stage. Define each parameter, including its format, the units used, and the codes for missing values. Informatics approaches that are pertinent in this step include the use of file formats that are non-proprietary, such as text or CSV files, so that they can be widely disseminated and read well into the future. Electronic data management tools such as REDCap can allow a researcher to create an electronic data collection form, which can enable direct data entry, instead of using case report forms, which require study personnel to manually enter data. Step 3 of the data lifecycle is data assurance, or integrity. Performing data quality checks on small datasets may be done manually, but large datasets may require automated procedures. Data provenance is important to ensure that we can reliably check how data is transformed from source to final analysis. Storage in commercial spreadsheet applications may not be ideal given the propensity of these programs to alter its contents during data manipulation. Informatics approaches that are pertinent in this step include automated data type enforcement, which can be implemented in electronic data capture instruments, and direct data transfer methods from source to storage. Step 4 of the data lifecycle is describe. Data must be properly annotated so that it can be understood and utilized in the future. Researchers should thoroughly describe how the data was collected, how measurements were made, and what data files are related to it. Currently, organizations such as CDISC have created a standard which enables data from clinical trials to be properly annotated and hence easily searchable and reused. Step 5 of the data lifecycle is preserve. This concept advises researchers to invest in resources that enable the long-term storage and security of research data. Informatics approaches that can help with these are the use of clinical trial management software or electronic data capture instruments which are deployed by the institutions instead of being managed by the researchers locally. Steps 6, 7, and 8 involve the processes of data discovery, integration, and analysis. Often, these steps can be summed up into one continuous process. There are a variety of informatics tools available, such as Weka and RapidMiner. Data visualization tools can help researchers visualize their data to find patterns such as rules and associations, which can be tested and exploited. Many of these tools are open source, and there are tutorials available for free as well. So that's it, the 8 steps in the data lifecycle and their respective informatics approaches. I hope this short tutorial has helped clarify what are the issues in data management and what informatics tools are available.